Lesson 1 for solution equilibrium. It goes along with the SE1 assignment on molarity. Molarity. The concentration of a solution is often given in molarity, symbolized by a capital M. Molarity is the number of moles of solute that would be dissolved in 1 liter of solution. To calculate molarity, you divide the number of moles of solute by the volume of the solution the solute has been dissolved in. The unit for molarity is moles per liter, which is usually written in short as capital M. So our formula looks like this. Big M, that's molarity, also known as concentration. We also use the term molar. Mole, that's moles. It's usually given to us in grams, and it will have to be converted to moles, so it can be used in this equation. And L is liters, measured in liters. So we're going to talk through the first 3 examples. After that, you will write down the remaining 3 examples that will be found in your handout. First practice example. What is the molarity of a solution that has 6.0 grams of NaCl dissolved in 2.0 liters of water? When I see grams, the first thing I do is switch it to moles. So 6 grams, I switch that to moles, grams on the bottom, moles on top. 1 mole equals the mass off the periodic table. Grams factor out. At 2 significant figures in the given, so that means I'll write down my answer with 2 significant figures once I've run it through my calculator. It said, what is the molarity? So I'm looking for molarity equals moles over liters. I'm looking for moles over liters. I just found moles. Liters were given to me in the question. I'll run it through my calculator. I'll wind up with 0.05133 moles per liter NaCl, which is then written as, final answer, 0.051 molar NaCl. Next practice example. How many moles of KBr are needed to produce 500 milliliters of a 0.010 molar KBr solution? So I've got 500 milliliters. That's going to have to be converted to liters. So big brackets, milliliters on the bottom, liters on top. 1 milli equals 10 to the negative 3. Run through my calculator. 500 milliliters is the same as 0.5000 liters, keeping my significant figures there at 4. Now molarity equals moles over liters. I'm looking for moles. To get moles by itself, I multiply both sides by liters. So the liters on the right side will factor out. So I wind up with moles equals molarity multiplied by liters. I'll sub my values in, run it through my calculator, and that's it. Last talk through example. How much water, so I'm looking for liters, is required to make a 0.120 molar Ki solution if we have 40 grams of Ki? So right off the top, grams, I want to switch that to moles. So 40 grams Ki, big brackets, grams on the bottom, moles on top. 1 mole equals the mass off the periodic table. Grams factor out. And then I wind up, well, there's 3 significant figures. So when I punch it through my calculator, I make sure I correct it to 3 significant figures, and I got 0.240960 moles Ki. Now, molarity equals moles over liters. I'm solving for liters, so I'm going to have to get liters by itself, but I also have to get it out of the denominator. So to get it out of the denominator, I multiply both sides by liters. So liters on the right side will factor out. Liters is now in the numerator. To get it by itself, I divide both sides by molarity. Molarities factor out. Liters equal moles divided by molarity. I'll sub my values in, run it through my calculator, and then correct for significant figures. Note it's written as just 2.01 liters as a final answer, not 2.01 liters of potassium iodide. If I'm looking for moles, at the end, I will write moles of Ki. If I'm looking for grams, I'll write grams of Ki. If I'm looking for concentration, I'll write molarity Ki. But for liters, I just write liters. Now for the real examples for you to take down. Note I have started a variable list. What is the molarity? So I'm looking for molarity of a solution made by dissolving 4.00 moles CuSO4 in 2.00 liters of water. So my liters are 2.00 and my moles are 4.00 moles of CuSO4. When I write molarity equals moles over liters, I've already been given moles and liters, so I simply have to substitute in. So 4 divided by 2 gives me 2 moles per liter CuSO4, which I will write because I have 3 significant figures in both the numerator and the denominator. I will write it as 2.00 molar CuSO4. Example 2, how many moles of NaCl are in 350 milliliters of a 2.00 molar NaCl solution? So molarity equals 2.00 molar. Liters, 350 milliliters, which will have to be converted to liters. 350 milliliters equals 0.35 liters. And I'm asked to find how many moles. Again, molarity equals moles over liters. I'm solving for moles. To get moles by itself, I will multiply both sides by liters. So liters on the right will factor out. So moles equal molarity multiplied by liters. I will sub my numbers in, run it through my calculator. That gives me 0.7. I will need 2 significant figures, so my final answer is 0.70 moles NaCl. Example 3. What is the concentration of a solution when 143 grams of potassium bromide have been dissolved in 2.0 liters of water? M is concentration, and it says what is the concentration? So that is what I'm looking for. Liters, I'm told I have 2.0 liters of water, and moles, I have not been given, but I have been told grams are equal to 143. And when I've been given grams, my first step in concentration questions will be always to switch those grams into moles. So 143 grams kBr, big brackets, grams on the bottom, moles on top. 1 mole equals the mass off the periodic table. Grams and grams factor out, and that means I'm starting with 1.201657 moles of kBr. Now, molarity equals moles over liters. I'm looking for big M, so that means it's already been isolated. I can sub my numbers in because I just found moles, I was given liters, I run that through my calculator, it gives me 0.6008. I've got 2 significant figures because of the 2 significant figures in 2.0 liters, so my final answer is 0.60 molar kBr. Example 4. How many grams of NaCl are needed to make 250 milliliters of 2.0 molar NaCl solution? So my concentration, I'm told it's 2.0 molar. Liters, I'm told I need 250 milliliters, which will have to be converted to liters. So 250 milliliters equals 0.25 liters. And then how many moles? Well, I don't know moles. And it's asking me in the end for grams. So I'm going to have to find moles first and then convert it to grams. So molarity equals moles over liters. To get moles by itself, multiply both sides by liters. So the liters on the right will factor out. So moles equals molarity multiplied by liters. I will sub in the molarity and the liters, multiply them together. That means I need 0.50 moles of NaCl. Now to convert those moles to grams. So 0.50 moles NaCl, nice big brackets, moles on the bottom, grams on top. 1 mole equals the mass off the periodic table. Moles will factor out. I run it through my calculator. That gives me 29.2212, which is equal to 29 grams NaCl. That's it. We're all done. You're good to start working on the SE1 assignment.